the indefinite integral. So what we know about the indefinite integral is that number 1 is that it does not have upper or lower limits. Number 2, the answer is a function, not a specific value. And number 3, it includes c, which represents the family of antiderivatives by accounting for any possible vertical translation of f, which means that the answer to the indefinite integral will include a plus c. So the first example I'm going to be using is a simple one, and it shows how to use power rule to solve an indefinite integral. So you can see that we're trying to find the indefinite integral of 2x to the 4th, and we know that the u value is 2x and the n value is 4. So what we're going to do is we're going to add 1 to the n value right here, and then we're also going to put the n value plus 1 on the denominator. So then once you do that, you come over here and you have 2x to the 5th power over 5, which can then be simplified to 2/5 x to the 5th, and then we always want to remember to add plus c whenever we're solving the indefinite integral. So that shows power rule and one of the basic examples of an indefinite integral. So after showing power rule in the first example, I'm now going to talk about u substitution for example number 2. So we're trying to find the indefinite integral for 3x squared plus 2x times e to the x cubed plus x squared dx. So we're going to want to use u substitution because we have this exponent here. So the first thing you're going to want to do is identify the u value, and to identify the u value you're always going to use, if there's an exponent, you're always going to use the exponent. So we know that this is the u value, so we're going to state that u equals x cubed plus x squared. And then next you're going to find the derivative of this, which we know is just 3x squared plus 2x. So now you know that du dx is 3x squared plus 2x. And then you're going to move the dx onto the other side so that we can isolate it to be du. So now we have du equals 3x squared plus 2x dx. So now that we have the du and we have the u, we can now use both of those values to substitute into here because they're the same values and identical values. So once you do that, you're going to end up with e to the u times du, because the u value will substitute into here, which would give you e to the u, and then the du value would substitute into the 3x squared plus 2x. So you would end up having e to the u times du, which we know that if we solve the antiderivative of it would just equal e to the u, and then we have to always add the plus c because it's an indefinite integral. And then after you do that, you're going to want to substitute back the u into the original. So we come back up here and see that u equals x to the 3rd plus x squared. So then we're going to replace that, and your final answer of the indefinite integral would be e to the x to the 3rd plus x second plus c, because like I said earlier, you always need the plus c when you're solving an indefinite integral. For my last example, I'm going to show you how to find the particular solution when solving the indefinite integral. So the example we're going to use is 4x cubed minus 6x squared dx, and f must contain 0.10. So first, we're going to find the antiderivative by using power rule again. So we had the 4x and we added 1 to n, and then we divided it by that new value. And then the same with the other one, we added 1 to the n value, and then also on the bottom we did n plus 1, and then like always we do plus c. So that would show us to have x to the 4th minus 2x cubed plus c, because the 4's would cancel out here, and then you would do 6 divided by 3 would give you 2. So now we have this right here, which would be the indefinite integral, but we want to solve for c to find the particular solution. So to do that, we're going to use the point that we were given, 1, 0, and we're going to plug it in. So when we plug it in, we plug in 0 for the y value and then 1 for the x value. So we plug in x here and also x here. And when we solve that, we get 0 equals 1 minus 2 plus c. And we do that simple math, and we get 0 equals negative 1 plus c, which we obviously know that c would equal 1. So now that we have this c value and we have this indefinite integral solution, now we would bring it down here and we would rewrite the particular solution, which would give us x to the fourth minus 2x cubed plus 1. And that includes the c value and the rest of the function, which would give you the answer to the indefinite integral.